Hello and welcome to this first video tutorial. So throughout the year, I'm going to create video tutorials to help you through your assignments. Sometimes it will be the actual assignment that you could follow along with. Sometimes it'll be an example of the assignment for you to use as a template for you to figure out your work. As always, pause the video as you need to, rewind as you need to, and make sure that even though you're watching a video, place question marks next to anything you do not understand. That way, you can ask for help in class when you need it. Let's begin. First, let's make sure we open this up in Kami. And our first lesson is going to be on scientific notation. Now, scientific notation is a way of allowing you to rewrite a number in regular form, that's called standard form, standard notation, in another way. Okay, now that other way looks like this. It's some number between 1 and 10 times 10 to some exponent. So now let's talk about that exponent. Well, it turns out that when we move decimals to the left, your exponent becomes more positive. That's going to be important, especially when you're dealing with negative exponents, right? When we move decimals to the right, the exponent becomes more negative. All right, so let's try a few of these, see how we got this. All right, in our number one, it says we have to turn all these numbers in part one here into scientific notation. So our first number is 0.000000786. Well, you can see the decimal is here. In order for our number to be between 1 and 10, we have to move the decimal over here between the 8 and the 6, or the 7 and the 7 and 8, which means you'll move it 1, 2, 3, 4, 5, 6, 7 times to make our number 7.86. Now is where we deal with the exponent part. If we move our decimal to the right, our exponent becomes more negative, hence -7. Since I moved the decimal to the right 7 times, my exponent is -7. Now, in a number like this, when you don't see a decimal, the decimal is always assumed to be at the end of the number, after the 0 in this case. You've got to move that decimal between the 3 and the 9 to get it between 1 and 10, which means we would move it 1, 2, 3 places to the left. That would give you 3.94 times 10. Now, since you move the decimal to the left, the exponent becomes more positive. Specifically, since I moved it 3 places to the left, it's going to be 3 times more positive, or 3.94 times 10 to the 3. Now, number 3 is an interesting one because 4.7 is already between 1 and 10. So we could just rewrite this as 4.7 times 10. And think about it. If the decimal is already between the 4 and the 7, that's numbers between 1 and 10, you don't have to move the decimal anywhere, which means 10 to the 0 power. I know it looks weird to write a number that way, but that is a correct standard scientific notation for a number that's already between 1 and 10. At this moment, go ahead and pause the video and try to do parts 4, 5, and 6 yourself. Then we'll resume and see if you did it correctly. All right, let's check it out. In number 4, The 0 would be at the end of the number since I don't see it. It's got to go here between the 1 and the 2. So it would be 1, 2, 3, 4, 5, 6, or 1.26 times 10 to the 6th power. Hopefully you got that one correct. In number 5, the decimal is obviously up front. It's got to go after the 6. I need to move it twice to the right, which would make it 6, or 6.0, times 10 to the negative 2. Since I moved it to the right, my exponent is now more negative. And in our last question in this part, the decimal is at the end of the 5. It needs to go here between the 1 and the 7, which means I must move it twice to the left, in which case I would get 1.75 times 10 to the 2, or 2nd power. All right, hopefully you were able to get those correct. Now, in the next section, you have numbers that are in scientific notation, and you have to rewrite them back into standard, which means the rules up here get worked backwards. Okay, think about it. If I move a decimal to the left, my exponent becomes more positive. So that means if I have a positive exponent, I will move it back to the right where it came from. Okay. If I move a decimal to the right, my exponent becomes more negative. So if I see a negative exponent, I will move it back to the left. That number of times. Okay, so I'm seeing a positive exponent. How did I get that? I moved the decimal to the left, which means to put it in standard notation, I will have to move that decimal back to the right 3 times exactly in this case. So this would be 6,170. Okay, let's jump down to number 10. Negative exponent here. To get the negative exponent, you had to move the decimal to the right 8 times. So to put it back in standard notation, you're moving it back to the left that same 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. What that basically means is I've got 7 zeros and then the 54. Really small number. And hopefully you can see why. This is a perfect example of why you would write something in scientific notation, because this is just an awkward number to write because it's so incredibly small. At this time, go ahead and pause the video and try your best to do questions 8, 9, 11, and 12. Okay, let's see how you did. Now in number 8, you have a positive exponent, which means you move the decimal to the left 4 times to get that positive exponent. So to put it back in standard notation, you must move the decimal, which is after the 7, 4 times back to the right, in which case I would get 70,000. Same thing in number 9. In order to get 7.31 times 10 to the 6, I needed to move the decimal 6 times to the left. I must now move it 6 times back to the right. 1, 2, 3, 4, 5, 6 would be 731 with 4 zeros after that, or 7,310,000. Number 11. In number 11, you have a negative exponent, specifically negative 3. In order to get that, you needed to move the decimal 3 times to the right. Well, now to put it back in standard notation, you're going to move that decimal 3 places back to the left where it came from, in which case it would be 0.20 placeholders and then the 67. And in our final question here, you have 9.59 times 10 to the 2. In order to get 10 to the 2, you need to move the decimal twice to the left. So now we got to move it back twice to the right, in which case I would just get 959. All right, now in our final section, you have a number that looks like it's in standard notation, but it's actually not. The reason why is the number out in front, the prefix of the number must be between 1 and 10. 0.2 is less than 1. 88 is obviously greater than 10. 30 and 28.8 are greater than 10. So you need to move the decimal, in this case, ones to the right, in this case, ones to the left, in this case, ones to the left, and in this case, ones to the left. So you have to move the decimal one time in order to get that number between 1 and 10. As you do, the exponent will change accordingly. Remember the rules. If we move a decimal to the right, our exponent becomes more negative. If we move a decimal to the left, our exponent becomes more positive. So in the example for number 13, I move the decimal once to the right. So that means my exponent has become one negative. One more negative than 6 would be 5. So this is 2.0 times 10 to the 5th power. At this point, pause the video and try and see if you can figure out 14, 15, and 16 with the same logic. Okay, now in number 14, I had to move the decimal once to the left to go from 30 to 3.0. So this is going to be 3.0 times 10. Now, since I moved the decimal to the left, my exponent has to become more positive. Well, one number more positive, -8, would be -7. In number 15, I had to move the decimal once to the left, so that makes my exponent one more positive. So 8.84, one more positive than 3 would, of course, be 4. And 16, again, I had to move it once to the left, so my exponent becomes one more positive. One more positive than -9 would be -8. 2.88 times 10 to the -8. Hopefully you were able to get these questions correct yourself. And I hope that you were able to gain something from this lesson. Thank you. See you next time.